Welcome welcome to our today's class. Today we want to handle integration by substitution. So as the name suggests, we are using substitution. So we are going to handle several examples. Our example 1, so we have integrate from -1 to 2 x squared over x cubed plus 4 squared dx. So it's making a substitution. So we're going to say let u be equals to x cubed plus 4. We are choosing u to be x cubed plus 4 so that we can be able to make a substitution for x squared. And we remember that substitution is the inverse of integration. So if we differentiate du dx, we're going to get 3x squared dx. But now we have x squared dx. We're supposed to make a substitution. We're going to make x squared dx the subject, so we're going to get x squared dx is equals to 1/3 du. Another thing that we're going to substitute at the upper and lower limits, we're going to get new limits. So when x is equals to -1, our new limit, we're going to substitute in u. We're going to get -1 cubed plus 4. That gives us 3. And now when x is equals to 2, if you substitute, you're going to get 2 cubed plus 4, which gives us 12. So we are getting an overall new integral, which is quite simpler. So we have 12/3, and then we have 1 over u squared du. But now our du has a third, and a third is a constant. So we're going to factor out the constant. So we have to integrate 1 over u squared du. Is quite simpler to integrate. We integrate normally. We are going to make it to be u to power -2. So if we are integrating, we add 1 minus 2 plus 1. We are getting u to power -1 over -1, which is simply -1 over u. But don't forget we have a third. So we are going to rewrite, we have a third, which is a constant, into 1 over u, and this is a negative. And now remember we have new powers, so that gives us -1 over 12 plus minus, so it's minus, we'll get plus 1 over 3, and remember our third is still there, it's not going anywhere. So you're going to use the LCM, and if we use LCM, we're going to get -1 plus 4, which is simply 3 over 12, and 3 over 12 is the same as a quarter. And now we have our third, and then we have our 3 over 12, if you simplify, you are left with 1/12 square units. So that's basically integration by substitution. And another thing, if you want to retain your normal, or if you don't want to change, remember here we changed our lower and upper limits. You can decide not to change them and remain with -2 and -1. That means you're not going, wherever we have a u after this substitution here, you're going to substitute back x cubed plus 4, so that you can use, so we can see here, so you can say or. So we have 1/u, which is -1/u. We're going to say it's the same as -1/x cubed plus 4. So when you substitute back, you're going to use your normal substitution of 2 and -1. So that makes it, but remember now you have 1/3. So we have a third here. So it's going to be 1/3 into -1 over, so if you substitute 2, you're going to get 1/12. You're going to get -1/12 minus, if you substitute 1, so you're going to get minus, which gives you a plus a quarter. Not a quarter really, but a third, because -1 plus 4 is 3. And not, so you can see we are going back to this step here. So in the end, you will still end up with a third into a quarter after simplification, which takes you back to 1/12 square units. So either of the two will work. So let's write here or. So you can choose whichever between the two, you choose one and then you work with it. So our next example is still on using substitution. So we have an example 2. Integrate 3 -1 x over root 7 plus x squared dx. Another tactic, someone will ask, how will I know I am supposed to, how will I know which technique I'm supposed to use? Each of the techniques is unique and can be easily identified. For example, if you are supposed to use substitution, you look at your problem closely, you'll realize in the numerator we have x dx, in the denominator we have 7 plus x squared, meaning we can easily get x dx from this whole thing. So we are making u to be equals to 7 plus x squared du, which means we are differentiating, we will get 2x dx, which implies that we can make, so we are going to have a half du is equals to x dx. And as usual, you go back and make your substitution. So as for in this method, we are going to use that second part where after differentiating, we're not changing the limits so that you can see it clearly. So we're going to have 3 -1. So you're going to have a half is a constant. So you're putting a half on the outside, we will be left with 1 over root u du. So that is a half the integral of 3 negative 1. 1 over root u is the same as u to power negative a half. Why? Because root u is the same as u raised to power a half. But now since it's a reciprocal, that's how we are getting to power negative a half, and then we have a du here. So after, when we are integrating, you're going to get a half into u to power negative a half plus 1 over a half plus 1, negative a half plus 1. So negative a half plus 1 is just simply a half. So you're going to get a half into u raised to power a half over a half. But now we know this, the reciprocal of this will be 2. So we are going to get a half times 2 u to power a half, which is simply u to power a half. But now remember that our limits are still 3 and negative 1. As I had said earlier, it means we are substituting back this u. So you're going to get u was 7 plus x squared. Now this is raised to power a half, and now we are substituting 3 and negative 1. Now that gives us 16 minus 8 raised to power a half, and you know very well raised to power a half is just simply square root. So we're going to get 4 minus root 8. But root 8 is 4 minus, so root 8 is the same as root 2 is, okay, the square root of 2 times 4. But the square root of 4 is 2, so you're getting 2 root 2. So our final answer is 4 minus 2 root 2. That's our solution using substitution. So as simple as that, you can use either way. You can use either way to get. And now there are some substitutions that will give you natural logarithms. So you substitute, you get a natural logarithm. Let's see an example. So these ones yield natural logs. We commonly call them ln. So you find that you have successfully integrated, but now you get an ln. So we have 2x plus 1, we have 2x squared plus 2x plus 7 dx. This one is an indefinite integral. Definitely we are making u to be 2x squared plus 2x plus 7. That means our du is 4x plus 2 dx. But now if you check 4x plus 2, you realize it's twice 2x plus 1. So meaning this one can be written as 2 into 2x plus 1 dx. So we are going to get a half du is equals to 2x plus 1 dx. Now after that, you're going to substitute back so that you can simplify our integral. This gives you 1 over u du, because du is simply 2x plus 1 dx. So but now our du is over 2. we put our a half outside, meaning we factor it. 1 over u, the integral of 1 over u is simply ln of u. So we're going to get a half, and now we have our ln of u. Since it's an indefinite integral, we are adding plus c. And now if we substitute back in place of u, we're going to get 2x squared plus 2x plus 7, and now plus c. So that is a function that yields a natural logarithm. Okay, we can now try one with a function which is a definite integral. So we have x over x squared plus 1 dx. So u is x squared plus 1, meaning du is 2x dx, which means we can get a half du. We're making x dx the subject, x dx. So we are going to change the limits. So the limits here, our upper limit is when u is 2, our new limit will become 5, and when u is 3, our new limit will become 10. So we are getting 10, 5, and then we have 1 over u du. But remember, du is over 2. So if du is over 2, meaning we can factorize a half and get 1 over u du. You can use anything, you can use dt, dv, as long as you understand whatever you're doing, so it doesn't have any problem. So we have ln of u, but now it's from 10 to 5. So here you'll have to know the rules of logarithms quite well. So you're going to have a half into ln of 10 minus ln of 5. Take note, here you're going to apply laws of logarithm. You cannot just subtract and then you say you'll get 5. No, that is wrong. So you're going back to your calculus and checking out the laws of logarithms. So you're going to get a half ln 10 over 5. So you're going to get a half ln of 2, and you leave here. They cannot cancel out, so don't go ahead cancelling them out. So thank you for joining us. Kindly stick on for part 2, which involves trigonometric functions that contain compound angles. Thank you and goodbye.